Good evening. Today I am going to be discussing the effect of household aerosols on algae growth. My name is Abigail Eades. I currently attend Tunstall High School, and this fall I will be attending Virginia Tech to major in human nutrition, foods, and exercise in hopes of becoming a registered dietitian. I chose this project because I'm an environmentalist, so I have a deep concern for the ecosystem and interest in environmental protection, and algae plays a major role in these ecosystems. Algae is important because it is at the base of the aquatic food chain, which fuels all other aquatic organisms. I specifically chose to focus on household aerosols because they enter the ecosystem very easily through pipes, drains, and runoff. The results of my experiment can be applied to the real world through controlling algal blooms and understanding growth patterns of algae. From reading sources and completing my literature review, I learned a lot about algae growth and its common patterns. Although current literature focuses on things that affect algae growth, no studies are present focusing on household aerosols and growth. Nutrients that can be found in the water are pivotal for algae to be able to grow, and without them, growth cannot take place. Altering these nutrients also harms the way the algae grows as well, because too many or too little of these nutrients alters the way the algae grows. If too much algae starts to bloom, it can sometimes provide advantages. However, there are many disadvantages, such as the extinction of species and the release of algal toxins. Furthermore, I learned that chemicals that enter ecosystems have an overall negative impact on algae growth. One experiment tested physical and chemical measures, which were flow velocity and the addition of copper, and it negatively affected growth. The addition of microplastics also stopped algae growth, and these microplastics very easily enter the ecosystem through things such as fishing nets and road runoff. Aerobic granular sludge is another issue that results from too many chemicals in the water, and it also negatively affects the growth of algae. Based on these conclusions, the general addition of chemicals to ecosystems has an antagonistic effect on algae growth. Lastly, I learned that many different naturally occurring elements have different effects on the growth of algae. The addition of phosphorus and nitrogen can spark algal blooms, which can lead to the release of algal toxins that are bad for the environment. Experimentation done with sulfur enrichment and starvation yielded that sulfur is a needed element for algae growth. Additionally, the incorporation of heavy metals, specifically lead and cadmium, halted the growth of algae. According to these sources, the type of element and level of exposure plays a major role into whether the element harms algae growth or not. That brings me to my final research question: what is the effect of household aerosols on algae growth? My research hypothesis is that if algae is exposed to household aerosols, then the household aerosols will have an effect on the growth rates of algae. On the other hand, my null hypothesis is that if algae is exposed to household aerosols, then the aerosols will have no effect on the growth rates of algae. My independent variable is the addition of aerosols, and my dependent variable is how the algae grows in response. I kept room temperature, light intensity, container size, amount of stock solution, amount of aerosols used, and the species of algae constant in my experiment. My control group was the containers containing just deionized water and algae with no aerosol applied. The top picture depicts the 5 aerosols I used in my experiment, and the bottom picture shows me applying the aerosol with a pipette to an algae container. Furthermore, I will be explaining the methods behind my experiment. First, I gathered the materials needed, such as containers, lights, algae, aerosols, and pipettes. I randomized my sample by using a random number generator and labeled each of the 30 containers with its assigned number, as shown in the first picture. I created a concentrate solution that allowed the algae to grow by mixing 1 liter of deionized water with 20 milliliters of the algal grow concentrate. I then dispensed a 1/4 cup into each of the containers. Next, I set up LED grow lights and adjusted them to ensure that each container would be equally exposed, as shown in the bottom picture. I set the timer to a 12-hour to 12-hour ratio. Next, I dispensed 2 milliliters of algae into each container by using a pipette. I then took each container and aligned them under the LED lights. I created aerosol stock solutions by mixing 20 milliliters of deionized water with 5 milliliters of aerosol, as shown in the first picture. The picture labeled Day 1 shows the original algae, but I decided it was not enough to get proper data yet, so I allowed all of the containers to grow on their own. I rolled each container every day to move the algae around. After 5 days, as shown in the bottom right, I had enough algae to start my experiment, so I started by weighing 4 milliliters of the algae water solution in each container and collected the numbers in Excel. Next, I applied 2 milliliters of the proper aerosol to each container. Containers 1 through 5 were my control, 6 through 10 was glass cleaner, 11 through 15 was body spray, 16 through 20 was grease buster, 21 through 25 was oven cleaner, and 26 through 30 was hairspray. After applying the aerosols, I shook the solutions to make sure they were evenly distributed. After 2 days, I extracted 2 milliliters of each container and weighed it on a scale to get the weight of the algae. I comprised the numbers into Excel with my previous data. I repeated steps 13 through 15 to get another set of data for comparison. I then compiled my raw data and conducted statistical analysis. I decided to run a one-way ANOVA test to analyze my results because my data met every assumption of this test. At the significance level of 0.05, the null hypothesis was rejected with a p-value of 0.015. This bar graph here depicts the average positive growth rates, or the groups where algae growth took place. These groups are my control group, the body spray group, and the oven cleaner group. The experiment took place over 12 days, and as shown in the graph, data measurements were taken on days 1, 6, and 12. Every group had a starting weight of 0.15 ounces. As seen by the blue bars, the control group had stagnant data that slightly increased over the 12 days. And this was expected because no aerosol was applied that could have slowed down the growth. Additionally, the body spray group and oven cleaner groups, as represented by the green and purple bars, also experienced growth. On the other hand, this bar graph depicts the negative growth rates, meaning the groups where algae growth declined over the course of my experiment. Again, data was collected on days 1, 6, and 12. Glass cleaner, grease buster, and hairspray are the aerosols shown in the graph that had a negative effect. As seen by the blue bars, the glass cleaner had the most detrimental effect. However, all 3 of these aerosols provided significant results by slowing down the growth rates of algae. Therefore, at the 0.05 level of significance, there is sufficient evidence to conclude that household aerosols do have a significant effect on the growth rates of algae. My results are important because algae is at the base of the aquatic food chain, so it fuels all of the other organisms and water environments. In the real world, due to algal blooms, along with the release of algal toxins, scientists are looking for ways to control the amount of algae in water environments. Therefore, my results are significant to get a better understanding of growth patterns and how certain aerosols that easily enter the ecosystem through drains, pipes, and runoff affect the algae in these environments. I think my results came out the way that they did because of specific elements and chemicals in the ingredients of the aerosols that I used. For example, I believe that the oven cleaner made the algae grow from 0.15 to 0.21 ounces because of its high concentration of nitrogen and phosphorus, which my literature review suggested can spark algal blooms. The first glaring limitation was the amount of time spent on my experiment. It took place over 12 days, so the limited amount of time could have affected my results. If I had let the experiment run longer, it possibly would have shown more accurate data regarding the effect of aerosols on algae growth. Furthermore, my sample size was only 30, so each group had 5 containers of algae. If the resources were available to access more algae and tools, then the sample size could have been larger, which would yield better results. Lastly, some of the equipment I used, which was all that I had access to, could have affected the results. For example, the scale I used could have been a more accurate one, where it provided more precise measurements of the algae. If this experiment was to be conducted again, the researchers should allow it to take place over a longer period of time with a larger sample size while using more accurate equipment. My research was a good basis for future research because I had sufficient evidence to conclude that aerosols do have an effect on algae growth, so this could inspire future research to be conducted more specifically on how humans can limit their aerosol usage in order to keep our ecosystems healthy. Out of the many skills I've learned over the course of my experiment, the few that stuck out to me the most were my understanding of how precision is important, how to be more observant through asking questions, and how simple research questions can open the door to endless possibilities for future research. To conclude, I would like to give a special thank you to Ms. Long for teaching and helping with the research process, Ms. Dillon for teaching me how to properly maintain algae, and Dr. Bocog for making all of this possible and providing feedback. I will now take any questions.
I'm going to, sorry.
Ms. Ashworth.
I have a question with your, the negative growth results, and you had stated that the glass cleaner continuously showed that reduction, and you had stated that may be something that you would be able to use in water systems. Why do you believe that the glass cleaner was so effective in reducing that?
Ms. Ashworth asked why I believe that the glass cleaner had such a negative impact on the algae growth rates. Based on my literature review, I believe that just the ingredients in the glass cleaner, probably a lot of acidic chemicals that kill the algae.
Okay. So if you're, which is good for killing algae, but if you're putting in a water system and it's acidic, there might be a problem with some of the water as far as it might change the pH. So maybe if you could use a buffer, that might have been able further on carry on from this experiment. But I just wanted to see if you were aware of that, and you seem to be.
Dr. Snow.
How did you come up with the method that you used to grow your algae?
Dr. South asked how I came up with the method to grow my algae. I based a lot of my experimental design on my literature review, so we read many sources with lots of methodologies, and it just was a continuous pattern of how they decided to grow the algae with the LED grow lights.
Thank you.
Mr. Taylor.
Yes, out of all of the aerosols that you tested, which one do you think has the highest probability of being introduced into an ecosystem in like the largest quantities?
Mr. Taylor asked which aerosol I believe could be introduced to the ecosystem in the largest quantities. I believe, and from my personal experience, probably the hairspray, just because using hairspray, you're right at the sink, that can easily enter the drains and get into the water environments, and that is the aerosol that I probably use the most.